Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about the upcoming 3D printer boom that's going to happen. So let's dive deep into it. So we have to understand this aspect, overhype. Now overhype is common for anything that is a paradigm shift. Now you have to understand, whenever we actually observe a paradigm shift, it overstimulates this puppy, meaning we get a bit too excited. So that creates a serious paradox of dip. After that, things chill down. So this idea of like innovation, whoa, it's gonna change the world and it's not gonna do anything, then it's like, okay. So it's a common thing. And if you ever notice stock markets, whenever a new basically company comes into the market, whoa, and then it's like, yeah, no. And then it's like, anybody who buys here, they're like, me good. So it's one of those things. It's a human psychological artifact, if you will. It is there, it will happen. You have to be just wise about it. You have to be just like, apply some brakes to it. Now, it has happened time and time again, even with plastics. Now, if today I say plastic would be a big industry, you'll be like, yeah, duh, it is the biggest industry. That's all. Here's the deal. Back in the 50s and basically just after World War II, plastic industry was coming to be, and people were going crazy. They were going cuckoo over it. They were like, dude, buy into plastics, man. Get the plastic stocks, man. It's gonna like skyrocket. Did it skyrocket? Absolutely. Did it happen quickly? No. So it also had the same thing. People were like, whoa, man, this is going to change the world. And then it slowly became thing. And composite fiber, when the fact we understand that we can build structures, solid robust structure, either with carbon fiber or glass fibers or just basic fibers, it was like, whoa, now we're going to build everything out of it. We're going to build planes, we're going to do this and that. Did we do that? Yes. But again, same thing. If you look at the news articles of time when it was first announced, it was like, whoa, and then it's like, no, and then just calm down. It's a common thing. Right now, you are seeing the same thing happening with AI. AI is the biggest paradigm shift we could ever achieve. We achieved it, and now everybody's like, we are going into that dip period where it's like, yeah, it's like so much hype, so much waste, and all that. It happens. It's a normal, relaxed thing. Same thing happened with 3D printer. 3D printer is around here at this point in time, meaning we had the overhype about it, and now we are reaching a point. Oh, it actually has potential. So basically, you have to understand, whenever we think it will change the world, we get too excited about it. And when it does not change the world overnight, let that be very clear aspect. Overnight, we lose interest. And that's a normal, natural thing to happen with humans. Basically, imagine going to back in time in 2003, just after basically peak of bubble crash of dot-com bubble, and talking to people is like, bro, now is the time, my man. Buy whatever you can, especially in like Apple, Microsoft, Google, Amazon, Facebook, Nvidia, AMD, Intel. We were like, dude, why are you crazy, man? Like, we already had this. But here's the deal. In 2003, if you try to talking to anyone, it's like, bro, tech is the new thing, my man. Tech. That's what's going to happen. Like right now, if you go into what we classify as $1 trillion club, almost all are tech. So we have Apple, $1 trillion, $3 freaking trillion. Then you have Microsoft almost reaching 2.6 million trillion dollars. Then you have one oil corporation from a dictatorship, so I'm not going to count it. Then you have Google, that's also like 1.9 trillion. And then you have Amazon, 1.18 trillion. It's like freaking trillion. And then you have Meta and other things. You get the point. Basically, everything that is dealing with technology, it's the new thing basically at this point in time. Imagine doing that here. So that's why you have to understand this curve. Right now, you're going to see the same thing. So people who are acquiring AI assets right now, and if they're the lucky ones, they're going to be like, so you have to understand, this is a normal cycle for all of us, where we get overhyped, especially when paradigm shifts happen. So that's why you must understand physics, engineering, and economics. If you truly see a path where it changes something, hold on to your seats. So this is the overhype part of it. So let's get our foundations, our bearings strong. So it is a time-tested technology. Now, like, wait a minute, isn't 3D printer new? No, it's ancient. So we had this puppy from 1980s. Basically, the moment we figured out CNC, computer numeric control. Now, another aspect is CNC actually came before CAD. Like, wait, what? Yeah, we figured out how to use CNC using punch cards. So before we can even just had a monitor where you can just do something, people can mathematically build things and make a punch card out of it and just do it. Of course, not too complex things, but we were actually good at it. So In 1980, somebody figured out a SLA printing, basically having a resin-based printing output, and it was a big deal. And it worked. The companies who jumped into that bandwagon that early on, and the companies who invented and patented it, they were printing money. However, they were heavily patent protected, meaning sometimes patents make sense. Meaning, let's say a company is like, hey, we have this heater technology that allows us to waste very little heat and very little energy, and we get exactly the right temperature. We do not have overshoot, everything is fine. Now here's the deal: should you be able to patent that technology? Undeniably so. Now imagine somebody patenting, hey, you have a printer that heats up. Like, wait, what? That should not be patentable, right? Like, if somebody says red camera company invents an algorithm that allows them to compress raw file in almost lossless manner, and compress it, file size is like 1/10 of the size, and then they save it. Should that algorithm be protected in patent? Absolutely. Should the idea of raw compression be patented? No. You're like, what the hell? No. But somehow Red got patent on that. And same happened with 3D printers. They were patented to so ridiculous extent where it's like, dude, did you actually patent this puppy? Like a chamber that has a heater inside it, that's patented. Not the type of heater. You could even have that, like, hey, if you have, let's say, infrared heater in a chamber, I could get that. It's like, no, heated chamber is patented. It's like, what? So it was heavily patent protected, like to stupid degree. Like every corporation wants to do that, but it's like there's a line of making good profit, and then there is line of stupidity. So it went to stupidity. Consequence, it was stuck. So growth from 1980 to 1990 to 2000 was very minimal. Like minimal. You will be shocked. Like billions of dollars being poured in, output is minimal, because everybody was like, oh, this is patented. Oh, this is patented. This is patented. So some professors were like, okay, enough of this BS. Let's get this shit done. So RipRap movement was created by this gentleman, the professor, basically. And in 2005, they started the idea of RipRap movement. Basically, build a machine that should be able to print another machine. Now, let this be very clear. This was very early days, and their idea was like, we should be able to buy ready-made components and then just assemble based on one 3D printer. And that's why if you looked at the RipRap board, it is designed in such a way that a pen plotter can allow you to print the PCB, and you can etch it and then have a that's how far they went back in 2005. And they planted the seed of open source. And here's the deal: you have to open source anything you do if you want it to be open source. Because if you do not, yes, it has happened in the past where somebody did something, openly shared it, but did not license it properly, as in like open source it, and then company literally took that idea, made it, and then they're like, yeah, now you cannot talk about this because it's patent protected. It has happened. Yes, that's why we have open source license, to protect against that exploitation. So because they were professors, they knew their stuff. They were like, they got it patented. Everything was patent protected, as in it's open source. You can go YOLO on it. You just cannot lock it for others. So things worked, and few patents expired. You have to understand, not all patents are 100 years old. Many patents are like very old, as in like how long it's valid. Some technologies are by design in such a way that only for 25 years you can have solo ownership, and company generally want to be ahead, so far ahead, like Sony will create a technology of like Trinitron, and then they're like, okay, by that time people will clone it and the patent will expire, we'll move to LCD. Then by the time people will create something unique, and by the time somebody's gonna clone it, we're gonna move to OLED. That's how companies generally try to do. So some patents of that backward 80s expired, heated chamber included. So those are tied, and this movement created something very fertile. What it attracted was enthusiasts and innovators. Once those people started to flood in, things happened. What kind of things happened? All the problems were solved, meaning the technology, that progression of technology from 1980s to 2000 was like minuscule compared to how much progression happened from 2005 to 2010. Like things were going, and these people were working for free. These people were sharing their idea. Amazing things were happening. Like things were going, and innovators there just like, I got this, fam. You have this problem, I got this. Like brick by brick, day by day, all problems were being solved. So it is a time-tested technology which has seen all its ups and downs. So 2010s happened, basically from 2010 to 2019. So slowly more and more tools start to reach the market. This is the time where people, you and I, start to talk about, oh, 3D printer is the thing. Oh, you can buy this thing. Oh, colleges are buying this thing. Oh, universities are buying these things. So it became a thing in 2010. Now, Here's the deal. The hardest part of a 3D printer is not the 3D printer, that's the easy part. It's the freaking slicing software. Like if you think what happens if I use a printer from 2010, as long as physically well built, as in like the lubrication is not dried out, it's physically able to do it, it's more or less same as today's printer. Only difference is the slicing algorithm. Back in the days, as in like if you look at the slicing algorithm of 2010 versus slicing algorithm of 2020, you'll be like, damn, how the heck we were that stupid in 2010. It's just like, it's very hard to take a 3D object, slice it, and tell a tool path to, okay, this is how you're going to trace out, and this is a plastic, that's how it has to be. Because again, computer can either make it perfect, and then it's like, yeah, dude, plastic does not work that way. It's not going to physically print out. So it's one of those things, like many subtle things went into slicing software, and it took a lot of brain power. Like how many people it will take to make a machine that can read the G code and make a 3D printer? Barely 100. How many people it will take to make a good slicing software? 1000. Slicing software from start to finish. I'm not talking about like, okay, you took the ready-made code of rip wrap movement and then just improved it. That's a different thing. From scratch, like, okay, me start from scratch, how far can you go? There are very few people who has that level of competency. So it took a lot of brain power, it took a lot of effort, elbow grease to get this puppy as reliable as it is now. And then driver electronics also started to become cheaper, because the motor is a fixed thing, it's a dummy thing, it's the same thing from 1970s. Like it has not changed. Of course, magnets have become better inside there. We used to have iron magnets, so now we have basically neodymium magnet. Yeah, that's improvement, but not like, whoa, we could not do this to like, whoa. But electronics, because of the development of computer industry, microcontrollers went from 8-bit to 32-bit. And I just did that change in my old Ender 3. I went from 8-bit to 32-bit board. It got cheaper and better. So not only you can buy like from same price as back in the day of 8-bit, now you can spend the same price. So that means it got exponentially cheaper, inflation, and you can buy a 32-bit. It's also improved, as in like when I first time switched my printer board, because I was like, hey, I wanted the auto bed leveling, and it was like 8-bit board did not truly support it. So I was like, okay, I'll just bite the bullet and get the new board. The board said silent board. I did not care. I put it, I'm like, holy damn, the fans are loud. And then it hit me. I was never hearing the fans because everything else was so noisy, as in the stepper motors. So it's one of those things. It's not only cheaper, it's also better. So that allowed the better software with better hardware, basically better command structure to work efficiently. Amazing things can be done. The printer speed that you could achieve at the end of basically 2019 was like, damn. So, and a lot of company at this point in time came to be. They looked at the market, they were like, hey, there is some money to be had here, we can milk this, and there's just a lot of new company came to be. You may have heard some of them, like Ultimaker, MakerBot at one point was so huge. Like they were showing their, I'm watching this like CES from long ago. So back in the day, they were like, they had a small booth and they got the whole, like as in like the area that Samsung gets nowadays, they were getting it. Like they had like big printers, like, it's gonna print a helmet in one go. It was like, whoa, and then they disappeared. Formlabs, Creality happened in that same 2010s. Prusa, same 2010s. So a lot of company came into be, and because of the software matureness, because of the electronics price drop, people just went into it. Like company after company just went into it. So this is in 2010s. Now we are in 2020s. So what happened? Well, now, as of now, 3D printer has finally reached a point which we call it just works. Meaning at this point in time, unless you are buying utter BS from no name brand, if you are buying the cheapest Ender 3, that is the cheapest printer available, it could be available as low as less than $200. Even in India, sometimes you can find it at 15,000 rupees, which is like free compared to speaking how much I paid for that. So it's reached a point where unless you are buying something really, really bad, it just works. And maker and tools, maker I'm saying, basically market and tool both have reached maturity, meaning a lot of 3D companies have just evaporated. And it happens, it's one of those things, like when something starts, hundreds of company comes in, and then over time, only some survives. And same happened with rocket companies also. You're seeing way too many rocket companies now. You know for a fact that in future, only few of them will survive. Most of them will disappear. That happens. So same thing happened with 3D printers. Like nobody was taking Creality seriously. Now they are like, I'm the daddy. So same things. And same thing is happening again. Bamboo Lab. Like even like, how the heck Bamboo Lab went from what is this company to like, this is the biggest name in the industry? Well, they figured out one thing. There was no problem with the slicing software. There was no problem with the hardware or electronics. The problem was marriage of all these three things, meaning the ease of use. It just works. So what they realized, the biggest problem in 3D printer is getting the first layer consistency. If the first layer is consistent, good enough, done, go home, sweet dream. And again, if you know that first layer is good enough, you can actually go faster. So that was another problem with 3D printer. It is still a problem. It's like it's slow. Like most people do not have comprehend how slow it is. Like I have to print a border for my PC electric box basically, and it's just a spacer bar. It's a 4-hour print. I do not even know how people have patience for like 3-day or 4-day prints. So you have to have a very good first layer, only then you can go YOLO on it. And they put LiDAR, not even joking, a micro LiDAR that scans the whole thing, and now it gives, okay, this print setting in this printer in this environment gives exactly what we are looking for, as in the software looking for, and then it's just like, I got you. So it has reached maturity, meaning you can buy even low conveyor printers if you are like, hey, I'm printing something very long, or I'm printing same thing again and again and again. At that point, this can be automate, just automate mass production on a 3D printer. That's possible now. So we have reached maturity level. So the biggest advantage is that at this point in time, if you know what you're doing and you have patience and you have money and time, of course, you can build top of the line printer at home. And I do not mean a basic Ender 3. I mean printers that are like, damn, like people have built Vorons that are so fast. It looks like, are you kidding me? They will make a bamboo lab like, whoa. Like that's how fast it is. And the build volume, the build chamber, everything. And some people have like, oh, I have built a printer that is the size of a person. I have built a printer that is printing from beads, plastic beads, not even a filament, plastic bead, because I'm using so much of it. Somebody has like, you know what would be nice? Super high temperature filaments. There are plastic that survives at 400 degrees Celsius. So if you ever noticed basically solder wicks, this puppy, this is plastic. How the heck it survives solder iron? Yeah, that's the problem. There are plastics that are very high temperature resistant. So somebody's like, what if we can print it? Like it could have been done, but nobody had like the toolkit needed for it. Now it's like, shut up, take money. There is software coded built already for it. Like people are like, oh, you want this chamber, this is how the metal's gonna expand, this is how, at 200 degrees Celsius. That's the thing. If you know what you're doing, you can build it today. You have guides for it. So top of the line in home. Heck, people have built laser sintering nylon powder printers at home. Like at this point in time, you do not have to worry about it. Like if you know what you're doing, you can build whatever you want. And then what about buying it? Buying is also reached a point where a lot of price ranges open up. If you are just starting out, which again, you may enjoy the tinkering phase, buy the cheapest Ender 3 you can and then upgrade it. Or be bit wise about it and buy Ender 3 that has silent board and auto bed leveling. Those two things will make your life much easier, and then you're gonna waste money on changing the cooling fan. Cooling fans are loud, for unnecessarily loud, and because they are 24 volt, you can't just replace them to 12 volt. So that's the whole point. You can buy very cheap and you can buy very expensive. Like Bamboo Lab is kind of expensive, and there are printers that make Bamboo Lab look free. So there are different price ranges available right now. You can have like printers that are used in manufacturing industry where they are building prototypes, jigs and all that jazz. They're going YOLO. So schools, colleges, company, all of them got it. This is the benefit of now, as in like the elbow grease put into from 2010 to 2020 is now yielding result. So what can we expect in the future? Well, this is where it gets interesting. Not so far 3D printer was like good. Now it's getting interesting because the first generation of students that have used 3D printer as a thing, it was like, oh, it's just a thing that prints. Not like I'm doing PhD on the 3D printers, that's why I know how 3D printer works, to like, no, I have printed this out, this works. That's how like people inherently understand how layer works, as in like, where how which structure, grain structure, they have to understand. Same way, if you're working with wood, you have to understand the grain structure. Same thing goes with 3D printer. If you know the grain layer structure, you will like, okay, I can make it strong, or I can make it fancy. So those students are reaching the fields now, meaning 3D printer has reached the ultimate stage of just another tool. Meaning I don't tell you about drill presses, I do not have to tell you about CNC, I do not have to tell you about laser cutters. Why? These things are just tools. You don't think about it. That's the whole point. That's where it should be. It's like, it is a thing, it just works. 3D printing is invisible now, and that's how it's supposed to be, exactly like CNC. You never go to a basically a car launch or a bike launch and companies like, we have used CNC machine to build this engine block. People will be like, duh, what else would you do? And same is happening with 3D printer. Back in the few years ago, every company was like, we are using 3D printer for this part, we are using 3D printer for this part. Now they do not even talk about it. They are like, yeah, we are using it. Like, especially for example, NASA spacesuits. They are like, yeah, there are so few of us, we cannot justify mass production. So we just 3D print many things. Of course, they do use it like pro $1 million printers that are like super high temperature filaments. But you get the point. Like, it's just a thing that we just use and we just put things. We do not think about it. Like right now, you do not think about this, like, Black Panther, like the crowns and all that was 3D printed in, like, resin. You don't think about it. It's just like, it's a thing. So what can we expect? Well, we are finally starting to combine all of the love, meaning more flexibility, as in what things can you do? Somebody's like, hey, we are printing things. What about we do it with metal? Somebody's like, hey, what if we are doing things with plastic? What if we do it with concrete? So we are adding flexibility to the tool. Somebody is building organs, somebody is building buildings, somebody is building a rocket, somebody is like, we are adding things to it. Like in your house also, you can go from PLA, that is bare minimum, to ABS, to nylon. Then there are some very high temperature peak, if I'm not mistaken. That is like, if this sort of high temperature plastic that can survive like 300 degrees Celsius or even higher than that. So all those are available. More flexibility, meaning you not only you can build a cosmetic piece or a helper tool to like, no, this is the tool, like finished, done, go home, to more experience. Like the better you get, like you cannot be just like, oh, 3D printer is just like CNC. No, it's not. It's like, it's completely different. Like if you know what you're doing, then you can utilize it effectively. If you do not, it's not. So you do need experience. Then the output will be GG. So we went from printing rockets, homes, to everything. At this point in time, if you can think about it, somebody's printing it. Be it bones, be it teeth, be it skull, be it heart. Yes, all of them are being printed as we speak. So we have reached the final stage. Basically, it's about to go boom, and we will never even notice it, because that's how it happens. That's how it's supposed to happen. Whereas, like, it came to a scene, everybody got overexcited, they got bit too to it, and then there's like clashed, and then it's like, oh, slowly. So basically, anybody who's buying stocks right now, effectively, if their bets turn out, they will be like. So future is going to be interesting. My special focus is in 3D printed rockets and homes. These things are like, somebody is adding like how many axes to it. Is like the highest I have seen at 22 axes in BMW CNC machine. If I'm not mistaken, that was the highest. It's like we send aluminum engine block goes in, machine comes out. Like as in like a block, engine block. I do not even know how many axes of rotation it had. So this is something like this. This will like remove your layer line constraint, where it's like, yeah, layer can be anywhere where you want it to be. So it can make really strong plastic parts for really complex things. So future is very amazing about 3D printer. It's just getting started, and the better it gets, the more invisible it becomes. So this was my presentation on 3D printer boom that's about to happen. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.